Box A was 3.45 kilograms heavier than box B. When 1.2 kilograms of items in box A was removed, box A became 4 times as heavy as box B. And we're asked, what was the mass of box A in the beginning? Okay, I think this is actually quite a simple problem, even though it could look a little bit difficult, because you might be thinking, well, I've got a change going on, and then I have A being 4 times as heavy as B. How do I know how to draw the bit in the beginning? So in a situation like this, where I often start by drawing the bit that seems the easiest to draw. So I'll show you what I mean, and then I'll show you what I would have done if I'd attempted it the other way around. So I'm actually going to start with we've got a before situation and an after situation, haven't we? And in the after, box A became 4 times as heavy as B. So if I draw a sort of basic unit for B, then A in this after scenario is 4 times B. Okay, so I've got these 4 parts or 4 units compared to B's 1. Okay, so that's that bit there. Okay, but what were we told? Well, actually, before I go, do you know what? I should label that, shouldn't I? I bet you thought that already. So I'm going to label this bit because I know that the amount of A is going to change. B won't change, but A does change. So this is after. Right. So it says that 1.2 kilograms of items in box A was removed. So I'm going to add another bit, and I don't know how big this bit should be compared to this bit, but it doesn't matter. I just know that I'll make it a different size to those. I've made this smaller. It might actually be bigger. It doesn't matter. What I do know, though, is that it has a value in this model of 1.2. It's 1.2 kilograms. So this represents the items that were removed from box A. Now, what else do we know? Well, we also know that box A, so when it had these 1.2 kilograms, so maybe we should label that. So this is, here, we'll do it down here. This is the before. And when A had all of this, we're told that the difference between A and B was 3.45. So where can I put that in? Well, this is B. Okay. And that's A before the removal. And we can see that that's 3.45. So what does this 3.45 include? Well, it includes 1, 2, 3 equal parts plus 1.2. So what that shows me is if I take 1.2 away from 3.45, I'm going to get the value of these 3 parts. So 3.45 minus 1.2 gives me 2.25. Now I know I'm working in kilos. I'm not writing it in, but I will check at the end that I have put my units into my answer. So what is 2.25? Well, that 2.25 that's the difference, okay, of 3 units. Okay, so that's this bit here is 2.25. So if we divide 2.25 by 3, we're going to get the value of each of these parts. And that is going to be 0.75. All right, so each of these represents 0.75 kilos. Now, have a look here. This is 0.75. I've drawn it's bigger here than this box that is 1.2, which is obviously a greater value. Again, that doesn't matter. All right. You draw it. You're making a guess when you draw it, aren't you? And it's not the relative sizes that matters. Okay. So I've got a lot of information here now. What am I actually asked for? Let's go back. What was the mass of box A in the beginning? Okay, which is this whole before thing. That's our question mark. So now we can see that that is going to be 1, 2, 3, 4 times 0.75. Okay, don't let the decimals panic you. It's just as easy as any other multiplication. You're only multiplying by one digit, one number, so that's perfectly easy. And that is going to give you 3 kilograms. Okay, 3 kilograms. In fact, do you know what? I'm going to prove it to you. I can sense that you don't believe me over the internet here. So 0.75. Okay, we're going to multiply that by 4. Okay, it doesn't matter that the 4's in that column. Okay, I'm going to put my decimal point in my answer. All right, so what's 4 times 5? Well, that is 20. So I'm going to put a 0 there and carry that 2 up here. If your teacher tells you to put it somewhere else, you do what your teacher tells you. Then I have got 4 times 7, that's 28, plus the 2 that I carried is 30. So that's a 0 there. And carry the 3. I'm actually got nothing there. So 4 times 0 is 0, but I have the 3. All right, so there I've proved to you it's 3 kilograms, and that wasn't a difficult calculation, was it? So 3 kilograms is 4.0.75, which is that part here. And then I need to add 1.2, and actually I can just do that in my head, can't I? So I should write down what I'm doing just to show my steps. So we're going to have 3 plus 1.2 equals 4.2 kilograms, which is, ta-da, our final answer. Before was 4.2 kilograms. Okay. Actually, what I'm quickly going to do is show you, because I drew this kind of backwards, what if I hadn't, that's just experience or my preference. So I could have done A and B. And what did I know? I knew that A was heavier than B. Okay, so I would draw a big bar for A and a smaller bar. And I know it's probably a fair bit smaller because this ends up being 4 times B. And then I have to think how I can remove some items so this ends up being 4 times B. So what I would probably then do is just do this. So that's 1, that's 2, that's 3, that's 4. And then this, whatever this bit is going to end up being my extra bit, that 1.2. Does that make sense? So so it's perfectly easy to do. I just prefer to draw it that way around. It all depends on, I might have, depending on how big I had made A, I might have ended up with a bar that looked the same as this. So I would have just made sure I indicated it wasn't the same size. That's all. Totally up to you.